everyone, and welcome to the first SolidWorks lessons by Team Phantom. This SolidWorks tutorial will go over a bit about how 3D modeling works and how SolidWorks works. So let's get started. So a bit background on what 3D modeling is. Well, essentially, 3D modeling uses multiple points in virtual space to kind of create or mimic real-life objects or whatever objects you desire to make. So by connecting these points, it kind of creates like these surfaces based on how you connect the dots in this place. And based on the interactions of these dots, you can create multiple like bubbles or barriers in three-dimensional space. So here are two examples of how you have like multiple points in space, but then in addition to that, how you can also connect the lines together. So on side A, this is the most basic form, which is essentially just drawing straight lines directly to in between each node to the closest node that they have. So this is the first iteration, the first and most simple way of modeling, which is called polygon modeling. And there's like multiple, like numerous and different ways to connect the lines soon after that, such as on the B side. It's much more much more detailed, but use the same amount of points as A. So what is 3D modeling used for? More often than not, it is used for basically anything you can think of and anything you can create visually from a visual standpoint. So, of course, many modern day movies, such as animated movies or CGI movies, you have use a variety of 3D modeling to enhance or fully create new worlds. Whereas video games, you can even create worlds and interact with them in like incredible and insane ways. More architecturally based programs are typically called building information modeling softwares. So they focus more on things like massive layouts for stuff like wiring and like air ducts and like plumbing, and as well as testing the design in catastrophic and like weather conditions, such as like natural disasters or just like extreme hot days or really cold days, to see what would happen to your building. So the main ones that we usually look at are SolidWorks or Autodesk Fusion 360, but there are a countless multitude of different programs. So some of these 3D modelings or CAD programmings, usually they do have some simulation tools, but there are some other programs out there that have much more detailed and more in-depth simulation software, such as like ANSYS and SimScale. So these let you do more in-depth fluid and thermodynamic analysis on our structures, which we will be using on things like aerodynamics for bodywork and such. So there's a couple questions I usually ask when I start programming in or using CAD. So the main, like some of these questions when you get frustrated is, why do we use CAD? Is it really worth using? Sometimes it's a pain in the butt, and sometimes it doesn't really work the way you want it to. So three main reasons I like to remind myself when things get really rough is that CAD allows us to do quick and infinite prototyping. So instead of doing all your testing on real world prototypes where you could like really mess up and you can't really reiterate these physical prototypes all the time, by using CAD, you can quickly make a bunch of different small iterations to one design, and you can basically do whatever you want with it, and nothing bad will happen to it. The second reason is simulation analysis. Without infinite prototyping, it's not really worth doing if you don't do a bunch of simulation tests on. Simulation analysis allows us to test different things on our designs in the virtual reality as opposed to making real-life prototypes and then testing there. This dramatically reduces cost, build, and time, which can be crucial to the design phase. So the third and most important reason, in my opinion, is optimization. So with many of your designs, you can make a lot of your designs just work just fine. They will be able to do what they do and just function normally. But the nice thing about CAD programming and like computer programming is that you can optimize your designs to get more efficiency out of your product. For example, we could use CAD on the chassis of the car to make it as light as possible while still maintaining certain metrics such as its torsional rigidity and strength. SolidWorks is very picky when it comes to hardware, so it kind of sucks this way. Gaming graphics cards and GPUs don't necessarily improve your quality of or your experience with SolidWorks nearly as much as if you were to start gaming. And the reason why is because CAD processes higher polygon objects at much and doesn't need to do it at such faster rates, whereas GPUs are optimized for quickly processing these images from lower polygon objects at a much faster rate to get your very high frame rates. If you really want to get an insanely good experience with SolidWorks, buying Quadro cards is probably your best bet. However, the one nice thing about SolidWorks is that it operates just fine using CPU power. Like it's optimized for just using CPUs because back in the day they didn't even have GPUs. Like GPUs didn't exist. So SolidWorks has been around for 30 plus years, and in that time frame, many people have used it and have become very accustomed and efficient at using the program. So that because of this, many websites and forums are out there to teach people how to use SolidWorks in a more effective and efficient manner. So three places that I use typically a lot is Javelin Tech, which basically is like a more formalized forum place for SolidWorks 3D modeling. But also YouTube is a very useful place as well, as it has many tutorials going through detailed steps, and they can be dedicated to just like a certain type of tool or like a certain type of modeling. So there are three essential file types in SolidWorks: the part, assembly, and drawings. You are able to build various individual parts into something called a part file, and these parts can be simply made from sketches or fully modeled objects. You can later reference all these parts in a single file called an assembly, which allows the designer to arrange all these parts in a specified manner, which allows the parts to interact with one another. Drawings can reference both assemblies or parts. These drawings, or engineering drawings, are blueprints for your model and are important for manufacturers and to the production of your final design. They include important measurements and tolerances that manufacturers will need to know. So, like any program, file structure is very important. Moving parts and assemblies around into different folders can wreak havoc to not only your workflow, but everybody else's workflow. For example, when you have a part in an assembly, that assembly will reference that file or that part in that particular location. So when you move that file out of that file location, that assembly that previous assembly will now be confused because it cannot identify what it was referencing. So that part will go missing and could potentially ruin your entire file. From personal experience, having a very strict file structure and naming convention minimizes these problems going forward. Because we're all working in a group, it is important that the overall file structure not be tampered with. Or if you're going to change something, notify everybody else. Avoid another thing about the file structure is to avoid duplication, as it will hamper the future assemblies. So it is important to keep the file structure that you had for the original file. So now that we have a more thorough understanding of how SolidWorks work, now we can start actually using it. So to start off, let's just start in a new part. So click new part. As you can see, there's the part, assembly, and drawing feature. Right now, we're just gonna focus on parts. So basically, to start making parts, you have to start from scratch, or like you can start from 2D as in sketches, 2D sketches. So in order to draw 2D sketches, first you have to define the plane that you're working in. Since you're working in a 3D space, you must first establish a 2D section that you're going to be drawing on. So the default planes are your front, top, and right plane. these are defined by like SolidWorks X, Y, and Z, internal X, Y, and Z axes. And to start a sketch, it's easier if you just click on which plane that or surface that you're drawing on, right click it, and then click the sketch button. So now that you're in a sketch, you can automatically know if you see these two icons in the corner. The blue one means that once you click it, it'll save whatever you've done in the sketch and exit it. The red X will discard everything you've done. So the first, so I'm gonna go through these 6 tools right here. Basically, the more you get familiar with them and the more used to you get them, it makes just drawing light things a lot easier. So first off, you got your lines. Basically, you can draw your lines or start your lines from any point along the reference plane. No matter what you want to do. Your trim tool can delete things really fast. So let's draw something like this. You may notice these little green icons that are near your lines. So, or when we go through these other drawings, you'll see these green lines as well. These green lines typically represent qualities attributed, or properties actually, that are attributed to these lines. So, for example, if I click on this line, on the left hand side will pop up something called line properties. So this green line that has the line going this way indicates that you have an existing relation called the horizontal relation. So if I were to delete this, hit the delete key on here, if I were to delete this relation, this line is no longer constrained to the horizontal direction, and I can move my drawing freely, or it's undefined. So an undefined sketch is something we'll go over in a bit. So to add a relation to it, simply just click on it and this thing will pop up, and then you can select one of the relations here. Another thing about relations that you can actually relate you can relate the line to other lines, for example. So example, if you hold Control down and select, let's say these 2 lines, now there's existing relations between the selected entities, line 15 and 16, which are just these ones selected. So let's say, for example, I want these 2 lines to be perpendicular to each other. So now at this point, you know that these 2 lines intersect at this point are perpendicular to one another. So as you can see, this line is constrained once again to the horizontal direction, but only because this line is vertical in a perpendicular direction. Okay, so these properties and relations for lines help define how your drawing is to be made in 3D space. So as you can see, these black lines down are here, and there's these blue lines right here. So that typically means that these lines are fully defined in this 3D model. So it has so these 2 lines are based on this origin point right here, right? And they also have a relation of let's focus on this line, for example. It has a relation of going in the vertical direction. So that means the line has to start at this point and it has to go up. But as you can see at the corner right here, it's actually a blue dot in this part, as opposed to a black dot like it is down here. So what that means is that this drawing doesn't know where to stop. So it can go as high as it wants or as low as it wants. It's important to make sure that your drawings are fully defined, so that when you start building things in the future, they won't things won't get like messed up as fast, essentially. And yeah, having fully defined sketches really helps rendering and rendering bigger parts. As you kind of make more parts and you put them into larger and larger assemblies, the more harder it is on your computer. Because let's say, for example, the computer knows that your line is vertical and it knows that it's here, but it doesn't exactly have like a defined space in the memory saying, oh, the line has to stop at, like, let's say 50 millimeters from here. it just kind of remembers how it's supposed to be, and then it has to recalculate its position every single time you move in space. So by putting these relations in here, or smart dimensions, in which I'll get to in a little bit, it makes your program much more easier to handle. It makes your computer handle these parts much more efficiently. So by adding smart dimensions, you can basically add lengths, and you can also add angles between two lines. So here is an example of over-defining a sketch. So for example, this line is vertical, and this line is perpendicular to this line, which is also vertical. So by having this third option right here, saying that it's 90 degrees, you're giving the computer too many defining traits that are repeating itself, kind of. So it's like when you want to design something, you have to make sure that you kind of leave one. You don't want to over define it, because you want to have everything kind of lead to one answer, if that makes sense. So like, if you know that this line is perpendicular to this line, then you don't need to say that this is 90 degrees, because it's already 90 degrees here, and this line is vertical to this one. So it's either redundant. So either to make this true, you would have to delete this quantity. Oh, well. So I deleted that previous perpendicular relation, and that now I can add this relation in. And now this line is defined with this line. So some good practices in the future as well. So the reason, like the nice thing about having, like, let's say a scenario like this, is that you can easily kind of adjust this whole shape easily without too much effort. I'm just gonna make this. So when you want to design something using sketch patterns, it's important to start thinking about how you want to define your object. So a good goal that I like to keep in mind is try to use as little smart dimensionings as you can, and try to use more of the line properties and line relations with one another. This kind of causes you to really think about what you need to define about your object, and how these smart dimensions and how you change these smart dimensions will affect your overall design. So in this example, I have a fully defined box, and these two dimensions basically allow me to change the height or the length of the box however I see fit. So as you can see in this example, it's pretty much the same shape, except it uses 4 smart dimensions instead of 2. So if I wanted to change the height of this box, 700, it's kind of weird. Like, I have to change more than just one thing about this box in order to make it taller. Or, oops. So while this design does work, it makes your life difficult as a designer. It just takes more time out of your day to constantly change like 3 different numbers, whereas you could have just changed one. So for example, let's say to make this design much more constrained but easier to adjust the design, you could delete these smart dimensions and simply make them equal to this side. So like this line can be equal to this line, and then this line can be equal to this line. And now you have a fully defined sketch, and I can adjust just one number, and then the shape will change how I would like it to be. So Solidworks has a very interesting tool that you could use when it comes to smart dimensioning things. So as you may have noticed, when you enter numbers, those are just, numbers. But in computer science, or just computers, you can replace those numbers with variables quite easily. So the same thing can be done in SolidWorks. So basically, to create a variable or a global variable, all you got to do is try to smart dimension something. And then instead of typing in a number in here, let's just make it equal to a global variable. So global variables can have also functions or something here. I haven't really figured this out yet. But yeah, essentially you can create a variable. So previously I already created a variable example, and that example variable is set to 10,005. But let's just set this to a new variable called Bob. So when you do that, it's yellow, meaning it's not created, but check mark means like it's possible. So I'm going to create a new variable called Bob. And Bob is going to be set to 9,000 millimeters. So as you can see, now this shape has this certain squiggly line here, or this sigma line equal to 9,000. The cool thing about this is that you can actually use this global variable and basically reference other smart dimensions to this line. So let's say I want this inner line to be 60% of this right here. So I would add a smart dimension in just like this, but instead of writing just 60% of what 9,000 is, I would just click the equal sign again, and then I would go into global variables and click Bob, or I can simply type in Bob and then multiply it by 0.6. Oops, you should do it beforehand. 0.6 times Bob. Actually, no, you can't do that apparently. You have to click on this. There we go. Sorry, my bad. You have to click on that. And now this is 60% of that. So let's say I want to make this taller again. Make it like the example. So it's 10,000 millimeters. Now this is changed to 60% of 10,000, which is 60. So this kind of helps you when you want to scale up when you have a certain design that you want to kind of play around with and kind of scale up and down and whatnot. You can actually view these equations by, if you type in equations right here, equations. A quick tip, if you want to see things, you can actually click something like this. And if you don't, you can probably find them in here, but it's really hard to find. So all you got to do is click that and click the show button. And it says show command line. And then it'll automatically take you to here where it shows you like right here. So click on equations. And in here, you can see that you have a full list of equations and global variables that are in this sketch right now. And in here, you can easily delete these equations and delete these global variables as well. So if I had to delete all of them, the sigma goes away, but it keeps the value. Now I'm going to really go through each of these tools in rapid fire succession. So you got your circles. You basically start at the origin and you measure out how far the radius is supposed to be, or the diameter. And it's pretty much only 2 measurements for you to fully define a circle. You got perimeter circle. So instead of starting in the middle, you start on the outside and then you kind of work your way out. So the distance from the center to where your mouse is your diameter. Splines is basically kind of like a crazy line. It's not really used for drawing things like profiles or drawing directions for where your profile is supposed to follow. This is more for surface modeling, which is a different tool entirely. So, and then you got your box one, you got a corner rectangle, and then you got a center rectangle, and you have 3-point angle, and then a 3-point center angle. Oh, one thing to notice, sometimes when you're drawing lines really quickly, sometimes you think you select the line, a point for it to merge, but sometimes it actually doesn't select it. So sometimes when you want to extrude a profile, like a profile needs to be fully enclosed. Otherwise, it won't be able to recognize that it has a hole in it. let's say for example, you wanted to do kind of like this weird shape, and you notice that there's a gap right here. If you try to extrude this, it won't be able to recognize that this is an enclosed area. See, unable to create a thin feature in the specified direction. So that's because this is not connected. So if this was connected, now that it recognizes that it's a fully enclosed shape, and it will do its thing. Okay, back to topic. Some other tools. So this is a pretty important. I like to use center point arcs quite a bit. It lets you round out corners, or just make hemispheric shapes. Similar to the circle entity, it lets you just draw a curved line. Ellipses are also pretty useful. So you have to define the center, and then you have to define the top and like the width and height of your circle. So there's essentially three different there are three different things that you gotta define about ellipses in order to make it fully defined. Oh, and four, actually, my bad. Orientation as well. So the reason why you don't establish a circle's orientation is because no matter what orientation you choose for a circle, it's always going to be the same. Okay. The next one is slots, straight slots or center slots or 3-point arc slots or whatnot. This is pretty niche tool. I don't find many uses for it, but it certainly is a useful mark. It's especially useful when you want to make like slots in flat sheets of metal so that you can slide different parts or slide different things in and out of. So yeah, it's pretty cool. Another one is polygon, so you can make hex heads really quickly instead of drawing the whole thing from scratch. It's really a pain in the butt. The nice thing about this is you can actually do as many corners as you want. So let's say you can go over to those left bar right here. I want, let's say, 12 points instead, because why not? Now, as you can see, this has 12 lines instead of 6. And I think all you need to define is the radius. Yeah, because before and the orientation, I believe. So let's say, yeah, this line is horizontal. The center line is horizontal. Therefore, this whole thing is defined. As you notice that it turned black. So black means it's fully defined. This center is not defined though, because as you look, you can make it bigger and you can rotate it. So if I were to put it on here, oh, I put it at the center point of this line, which happened to, so it's fully defined now. Okay. And lastly, there's something called fillets, filleting lines. So basically, any corner between two lines of some sort, you can just basically add rounded edges. These rounded edges is actually pretty important when it comes to manufacturing, because most things when you manufacture in real life don't actually have sharp edges, like full 90-degree edges. And more often than not, you actually don't really want full 90-degree edges either, because those can be kind of dangerous and annoying. So yeah, important to include fillets in your final iterations. You can change the fillet sizes by going over to the left-hand side and changing the radius. So this is a 5 millimeter radius, and you can make it a lot bigger like that if you want, and then it will kind of cut off those edges and then fully encompass what you've made. So there's some other tools in the sketch bar that allow you to kind of go a bit faster, or with patterns like mirroring, like very repetitive patterns in both like the rotation, like in a linear sketch patterns or a rotational sketch pattern. So let's just start with let's say you wanted to have there's a screw there's like a piece of metal, and there's got like 4 screws in 4 corners. So instead of drawing 4 screws or 4 holes in this circle, you could instead just draw 1 and fully define that. Fully defined, let's say this circle, 300, and then fully defined this one, 45, and then this one, let's do 20, and this one, let's do 100. So instead of doing this whole cycle 3 more times, instead you can choose something called a linear or circular sketch pattern. And what this does is basically it rotates everything that's selected about the origin of this. So keep in mind, if you did this whole sketch around a point that's like, let's say over here, it will not rotate around that center point. So to do that, all you gotta do is, So all you gotta do is click the circular sketch pattern and select your entity. And as you can see, it has this distance that you can adjust here and where it goes around. So it has 4 instances of repetition, but let's say instead of 4, you have 8. Now you got 8 holes. Let's say you don't have 8, and you have 20. Now you got 20 holes. It's a much faster way than doing it individually. The nice thing too about this is that you can easily adjust all the distances simply by, oh, I forgot to select both this line and this. So let's say you want 20 of these, or let's say 15. 15 of these. Now all these lines are fully defined and the distance is fully defined. So let's say the orientation of this actually does matter. So let's see. So this was kind of like it was on a big piece of metal, for example, going upwards. You can change the pattern, the circular pattern, by simply changing this angle over here. So 30, if I change it to 30, then this whole thing kind of rotates to match that point. Or you want to make it a bit further away from the center, you can simply change the radius distance, and they all move away from the one spot differently. So a bad example of this is if you had to do this by hand, then let's say, like if you did all 15 of these circles by individually changing them, it would take you like 20 minutes just to like change the radiuses of everything. So that's one method of doing. That's one example of using a linear sketch pattern or circular sketch pattern. Here's a linear sketch pattern. So let's say I have a giant piece of metal, and I want to kind of have let's say I have a giant like sheet of metal, and I want to have repeated hole, like square holes in the middle in it, kind of like this. So if I were to simply define this, let's say I wanted to have rectangular holes 100 by 400 millimeters big, and they're at the center. They're kind of at the center, and it's about, let's say, 200 millimeters away from the center, from the left side. And it's at the midpoint from here. So from here to this center point, you can choose 700 divided by 2. That gives you the point. But I don't really want to draw every single one of these rectangles, like how many given times. So instead, I can do something called a linear sketch pattern. And I can select basically, I can basically select the entities that I want to duplicate here, and then move them over however far I would like. So let's say every 200 millimeters. The spacing, as you can see, the spacing from center to center is 200 millimeters. And now I got my hole punches. And now I can increase it to how many times I want. So there's two numbers. Oh, there's two patterns. Now let's say I want 10. Now I got 10 holes. Or maybe I want 12. 12. Sounds good to me. Now you got 12 of these giant holes. But let's say instead of it being 400 centimeters across, you want it to be like 500. Now all of them change at the same time, and you didn't have, all you had to do is change one number. You could also use the linear sketch pattern to not only go in horizontal directions, but vertical and diagonal as well. So to go in the vertical direction, all you need to do is change this number right here from number 2 to number 1, and then change this number to however many times you want it. So let's say 10. Now you're able to change the direction you want in the Y direction. So let's say I want it every 300 millimeters. Oh, I didn't select it. I have to select this object. So now it goes all the way up to here, but looks a bit too much, so I'll just lower that. Now it all fits on there. There, now it fits better. But if, let's say you wanted to actually use both, so you can actually select both of them as well. And now you kind of have a grid pattern, if you want to say it that way. And now you have like a grid, like a whole pattern, a simple whole pattern just from one sketch. The nice thing too is actually you can change this direction as well. So let's say you don't want a square pattern with like a kind of like a grid-like pattern. Let's say you want it 45 degrees. So now this kind of creates a different shape that you have. And so one more tool that we could use is it's called mirroring entities. So mirror entities kind of basically does what you think it does. Essentially, all you need is a profile and a line of reflection. So let's say for this box, I wanted to draw kind of like an H shape going across it. So instead of drawing out an entire H, I could do something like this instead, where I kind of draw one part of the H, an L shape to be exact. And then using the mirror entities thing. So first you have to kind of read what this says. So this says entities to mirror. So I would hold control and then just click every single line that you want to mirror. And then when you click mirror about, this will mirror about whatever line you select. It can't be a circular line. It has to be a straight line. So to make the bottom half, I would select this line right here. And now you got this profile of the H, but I want to get it to the other side. The nice thing about that too, you can do that too by simply selecting everything here. You can mirror this side too by clicking everything here as well. Mirroring about this line. And now you have your H shape on here. And then the cool thing is, to fully change it, all you gotta do is kind of define this length. And then this length. Much less work than fully, let's say, drawing this by hand. You would have to kind of first draw out all the lines, then add in all the line relations, and then you would have to add in all the smart dimensions. So instead of taking out like 20 minutes of your time, this took like 2 minutes to do. Okay, so for your first assignment, try to replicate this aluminum extrusion cross section. So as some tips mentioned in this lesson, try to use as little smart dimensioning as possible. Alex will be posting an answer video next week before the next week's lesson. And the second assignment is to replicate this 80 by 80 standard aluminum extrusion. But the difference between the first one is that this one should be scalable in both X and Y directions. Okay. Thanks for watching. Good luck on your assignment, and I'll see you next week.